You're listening to China Manufacturing Decoded from the Sofeast Group. Hi, welcome to episode 294 of the podcast. Adrian's hosting again. Renaud's joining me. Hi, Renaud.
Yeah, how you doing?
Yeah, good, thank you. You?
Yeah, not bad. Catching up on stuff. A lot of very busy little things and a few exciting projects.
Yeah, we've had a lot of customers visiting recently in Jillian in
Yeah,
Dongguan, right? So you've been over there face to face talking to a number of different customers with different projects.
yeah. I'm not always there, so not all of
No.
them, but quite a few. Yeah.
That's great. Excellent. If you're wondering what a Jillian is, I'll leave a link in the show notes. We'd love to hear from you about your next manufacturing project. Today's topic, Renaud, fail-safe design principles. Okay. It's best to start with kind of an example, right? So we can get a taste of what we mean by fail-safe design, and also the kind of thing that is a failure, what we're trying to avoid.
Oh, wow. Yeah, just the latest example I was reading about is the way to open a door of a Tesla car when you're at the back and the electronics stop working, which, sometimes happens, right?
Yeah, yeah.
And a lot of people were kind of confused, like where's the mechanical handle to open it? And it's different in different models. So people can get confused. And some of the models is really quite obscure how to do it. It's not visible. You need to go and like guess with your hand, is this like this? If I pull on this latch, is it going to do something? But sometimes in an electric car, if the electronics are failing, if something is causing the electronics to fail and the batteries to go overheat and, thermal run away and so on, you really don't want to be caught in that car, but the
No.
normal locking system doesn't work. So that doesn't strike me as a very, smart design when one thinks of passenger safety, right?
Absolutely. Didn't this lead to a debate in Europe about whether they might even outlaw the hidden door handles for automobiles?
Um, Maybe I'm not sure. The thing is, there's a lot of electric lock systems, right, in
Mm.
buildings, and in 99% of them, by default, if there's no electricity, it will unlock. Because usually, there's no electricity because there's some kind of issue which might also cause fire, right? So
Mm.
people need to be able to evacuate pretty fast. You don't want them to be locked in a room, right? So by default, it unlocks. Now there's a few exceptions like the server rooms. Maybe someone might try to penetrate it by cutting the power supply. So in that case, it's the opposite. By default, it stays locked. But there's only a few very specific exceptions. And why didn't they do that at Tesla?
Mm.
Go and ask them. I think it's
Yeah.
just people who were in a rush to push a new vehicle to the market based on the grand vision of beep, hold, who did not really want to care about these kind of things.
Oh,
And
dear.
that's it,
Yeah, yeah. That's
I think you don't need to look for any further than that. The root cause is kind of clear to me.
that's an interesting example. And I mean, this is really the question that we're answering here. When we are developing the product, are we thinking about the instances where if X goes wrong, how do we ensure that the users of the product aren't put at risk? So in this case, if
Yeah,
an electric vehicle is kind of on fire or the electric system is failing, and how do we ensure that the doors aren't locked, locking people inside the vehicle, for example?
right,
Yeah.
right, exactly. Yeah,
Okay, great. So that sets the scene. If we talk about fail-safe design, then there's kind of like a process to go through for this kind of design,
yeah,
right?
yeah. Basically, well, there's no one way to do it, right?
Yeah.
People come to it from different ways, but if you want to have some structure when you're designing a new product and you want to think, wait, like let's do some planning first before we go into the details of the design. Like first we have some kind of concept of what the product is going to be like and so on. Okay. And then before we spend a lot of man hours and spend a lot of money on materials and so on, let's pause and think, right? And then the typical kind of thinking goes, what kind of errors might lead to some kind of failure, which might lead to a hazardous situation, which might lead to harm. And
Mm,
harm is, in the widest sense of the word, it might be like personal injury or death. It might be destruction of property, right? It might be a lot of things, but basically, what could go wrong? And like when it goes wrong, yeah, what kind of catastrophic failure might happen? You really need to think of these type of things. Okay, so such as, okay, if there's loss of power, but there's still people inside the car and they need to run away because there's batteries there. And, in some cases, the batteries can catch fire and explode and so on. Well, it's very, very dangerous. Okay, like, are people going to be able to get out very fast? Right.
mm,
And, oh, no, because the locking system, the locking mechanism is not going to work. Okay. So we need a way to allow them to get out. Okay. And then they came out with, okay, this is gonna be like another very discreet lock, like, but like the car has to be like amazing during the test drive and so on, right? So the design has to be like very pure and very nice. So we don't want something ugly just for the sake of safety. That's
mm,
where it goes wrong, right?
mm,
You, there's other ways to think about that. Obviously, if you think of users and what could go wrong because of the interaction with the user, then there's a lot of questions like this. Okay, what kind of users first are you going to use it? Is it going to be kids? Is it going to be very old people? Or whatever, mentally challenged people? Whatever. Who's going
mm,
to
mm,
interact with this product? What are they going to do? If it's a toy that you design for a 5-year-old, it's not the same as a toy for whatever, a 10 or 12-year-old, which might go into very bad abuse, right? So if they abuse it, okay, it's not really, it's not the way it should be done, but still, the design should still be safe. Like, if they abuse it, is it likely to break into small parts, that maybe the little brother or little sister might ingest, especially if there's these button batteries which can lead to death
mm,
within a short amount of time if they're ingested, for example, and they get stuck in the throat and so on. Well, is it likely that these kind of things might happen? And how can we tweak the design maybe to make it much less likely, right? So you can start from the product and the errors that might happen, and you might start from the users, but there's a logical process here, right? And usually it's a very good sign when we talk with people who've been developing a product and then they took the time to do a structured risk analysis. So structured risk analysis could be bottom up or top down, right? If it's bottom
mm,
up, it's going to be in the form of failure modes and effects analysis, right? FMEA on the design or on the system. Okay, so like listing all the kinds of things that can go wrong with the product and the way it's going to be used and so on, and then thinking of what the consequences of that, how likely is it, and so on. If you want to do it top down, which is a good compliment, then you do a fault tree analysis and you think, okay, so for this product, to catch fire, what would be required? Well, to be fire, you need, certain kind of gas, like oxygen, you need a spark, you need like, and then how could these conditions, each one of them happen, right? And then you have probabilities, and you calculate the probability, and then if it's too high, then yeah, you got to go back to the drawing board and rethink the product. Maybe let's add some redundancy here. I don't know, let's change the shape of this mechanical object, because in case it is pushed too hard, then it will puncture through the the gas tank, right?
Mm.
And if the plane was kept on the tarmac in a very hot weather, and the fuel produced a lot of gas and so on, and then it goes into that, and there can be a spark, and then you have a disaster like, what is it, TWA 800? I forget the 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 the, um, the flight number. Basically, the flight that blew up above Long Island, I believe, in 1996. Well,
Oh,
these kind of
yes.
things do happen. They do happen, and you know, if people had been thinking about that upstream, then maybe it would just have taken them 1 or 2 hours to make a little change. Okay, now it's less sharp, so it's less likely to puncture the fuel tank, and and in the end, you save, I don't know, 300 people, and I don't know how much money was lost, and so on, right?
Mm.
So that's it's always good to take some extreme examples, because it's kind of fun, even if it's really catastrophic, obviously. Okay, but it's maybe fun. Fun is not the right word, but it really captures the imagination, right? And it gets people to think, right? So that's why I tend to
Mm.
refer to the worst cases.
Well, yeah, of course, but those are the most high-profile ones where some
Yeah.
of these questions haven't been answered, so they're always gonna be more kind of in mind. But for normal everyday products, the kinds of products that a lot of our customers will make, electromechanical products. Okay, they're not an airplane, but actually, this kind
Mm.
of fail-safe design, it's still very valid.
Oh, it's the same principles, basically,
Mm.
right? You you are, well, let's not talk about Boeing, because
No.
poor of them. Like, okay, their management has been so bad for so many years. Okay, they don't stand a chance. But let's say Airbus or Comac, right? I hope they also learn from all this. The Chinese airplane manufacturer, I
Hmm.
get to believe so. So let's say Airbus design the next jet, they will tend to ask a lot of questions that, and the next, I don't know, uh, $1 million company that thinks of the next toy, let's say,
Hmm.
right, will tend to use the same kinds of tools and the same logical approach if they do their job well. Now, of course, like, the toy manufacturer is going to, make some prototypes, just send them to a compliance testing lab and say, okay, guys, what do you see in this design that you don't like, and do some of the testing based on the safety, blah, blah, blah. Okay. And they would pay a few $1,000s for that, and hopefully they've done some kind of risk assessment up front and so on. And at Airbus, they will spend, 1,000 times more resources to think about safety, and maybe more than 1,000 times more. And they will do a ton of software simulation. They will subject some very expensive plane prototypes to some testing, right?
Yeah.
It's very, very different, of course, in terms of the amounts engaged, but the principles are basically the same.
Okay. Shall we talk a bit about those principles then?
Mm. Yeah, sure. A few ideas, right, that I listed are: first, if you have a simpler product, there's let's say there's fewer opportunities for failure, right? And that's why, for example, German cars, like I'm talking about let's say the high-end German cars, they tend to add a lot of complexity to get to a really nice result. Okay, and a lot of people say, "Well, that's a bit over-engineered," Do we want to pay for that? Okay, maybe yes, maybe not. Maybe it brings some value. Okay, but the problem is, uh, then they cannot be as reliable as
Mm.
a high-end Toyota or Honda or Nissan, I should say a Lexus or an Infinity, or I forget those high-end brands, because
Hmm.
Japanese companies tend to avoid complexity. They try to find the right, how to say, the right balance between, yeah, really great experience for the user, but without adding a lot of bells and whistles, right?
Mm.
Now, maybe the perception of quality might be higher for the German cars, but the reliability in terms of like no failure, no problem will be better, objectively on the Japanese cars, right? And that's very,
Mm.
very general. Okay, I'm really generalizing here, but kind of comes out in studies by JD Powers and so on. Okay. So simplifying the product is a big one. Now, of course, to prevent failures and so on, you might have to add complexity, like, oh, maybe I don't know, this this electronic component might fail, and then that's a problem. It has, I don't know, over the next 5 years, maybe it has a 10% chance of failure. Then we add redundancy. Maybe we add another one in parallel. Okay. Then you kind of increase complexity to an extent. But it's better if you start
Mm.
from a simpler product. I think that's really my point here.
Oh yeah, absolutely. Less to go wrong. Simply simple as that.
Yeah,
Okay.
right. And redundancy, yeah, I just talked about redundancy.
Yeah.
So everybody still has the Boeing 737 MAX accidents in mind, right?
Yeah.
The whole thing comes, okay, there's several mistakes, right? Like they didn't tell the pilots about that, different software, but there's, it's okay, the training from the other 737s can just carry over, and like no need to tell them about this change, like these kind of things really, really made a lot of pilots very mad, okay, for good reason. Okay, there's several mistakes, but they were relying on only one sensor
Mm.
for the angle of the plane, right? They were the what they call the angle of attack sensor. And so if that one has a problem, which sometimes happens, then the plane believes is going way up, and then the software will correct automatically and stabilize it, except that if the gauge is not working, it will drive the plane into the ground. Okay.
Hmm.
So that's an example. I mean, if they had done a proper risk analysis, they would have, this is absolutely not acceptable. I just
Mm.
still don't understand how that happened. And there's a lot of things, right? But the airplane industry is just really amazing, because over the years, as they say, all these safety safeguards, precautions, fail safes have been written in blood, right? That's what they say. Because every time there's an accident, in a lot of countries anyway, there's a very, very serious investigation with a very serious root cause analysis. So for us in the field of quality, reliability, safety, that's like an excellent training. That's
Mm.
really, really excellent. All these NTSB investigations in the US and so on, like it's just so interesting. So anyway, I have a lot of examples, but maybe for the sake of time, no need to go into that. But I
For
believe
what?
there's a past article where we talked about that.
Yeah, yeah, we did. Yeah, I'll try and link to it. For redundancy, the
Mm.
one I'm thinking of is maybe like medical devices. Well, like electronic medical devices that might have a battery backup, for example.
Yep,
That's a
yep, you can
typical.
say that.
That's
Yeah,
that's kind of like one that's maybe a little bit less niche than airplanes, which are
right.
obviously.
Yeah, there's a lot
Uh,
of anything that has a battery, right? There's a battery management system, BMS,
mhm.
and it includes a lot of special logics, like, a lot of them have a temperature sensor. right? And then
Mm.
when the temperature goes up to a certain amount, a certain level, poof, cut off, That's just an example. Like,
Yep.
stop having it work, stop having the battery charge, like, it's got to cool down because if this lithium battery, keeps getting hotter and hotter, we might be in trouble. At
Yep.
one point, we cannot stop it anymore.
Mm. Yeah, absolutely.
So, yeah, that's
Okay.
redundancy and other fail safes, right? That's not redundancy,
Mm.
what I just said.
So
Um, and yeah,
another one is about human error.
yeah. So a lot of this is, let's say, triggered by users, right? The interaction of the user and the product is very, very important.
Mm.
And well, in manufacturing, in assembly, any manual operation, basically, a big theme is how to mistake proof or error proof the process, this operation, that operation. And a very, maybe a simple example to think of is, let's say you're making, I don't know, tables made of wood, and then the people are gonna be drilling the holes in the feet, okay? And sometimes they drill the hole as needed, where they present the part and into the fixture all the way to the end, and then drill. But from time to time, they will present it, upside down or whatever, 90-degree angle or something.
Mm.
And it's actually possible to do it. So yeah, they do it 5 times, they're gonna do it right. But they work 10 hours a day, they do that for a week continuously. They're gonna make mistakes, right? You make a million tables, you're gonna have some defects because of that, right? And it is very, very annoying for users because maybe they receive everything flat packed. No, so nobody really assembled the table, and nobody found the problem. And then you go to the shop and you get that, and you bring it back to your home, and you 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 put the table together, and then you find, oh damn, it's it's not, it doesn't get assembled. It's just an example about error proofing, but
Mm.
there's a lot of examples. If you can make it kind of obvious how to use your product, that really helps, right? So
Mm.
color coding things, like you buy a new computer, you need to plug the cables at the back, so the green one goes into the green port and the blue one goes into the blue port and so on. Do that as much as you can, and it's really going to be quite positive, right?
Mm.
So think about the human interaction.
The good old British plug for
Ah,
electrical
yeah,
devices. I know you got them in Hong Kong,
exactly.
right?
Yeah,
You can't go wrong with it because it can
exactly.
only earth itself if you just can't insert it otherwise. Yeah, yeah.
Yeah, that's one of
Any
the best examples. Yeah,
any
simple.
American any American listeners listening thinking British plug, I guess
Ah,
I'll have to
ah,
try and leave an image of it or something because it's very different to what you've got there in the States. But yeah, yeah,
right,
it's a good example. Okay.
exactly.
Are there any trade-offs if we're doing this? I mean, the one that comes to my mind would be potentially cost.
Um, well, it's cost in planning, right? So
Yeah.
planning, and you make some little design changes, or make this a little bit less sharp. So if it's pushed into the fuel tank, it's not going to puncture it. That might cost nothing,
Mm.
right? It's just an example where you design it differently, and that's it. You'll change in the CAD drawing even before prototyping, right?
Mm.
So in some cases, it costs nothing. Some cases, yeah, you add redundancy that will cost a bit more.
Mm.
Um, like we work on a product that does something to water. I cannot say anything more than that.
Yeah.
And for example, the product, one of the worries is, well, what if the pressure of the fluid going into the product is way higher? Like we cannot really control that. And then the customers answer is, oh, well, yeah, that might be a problem. So what can we do? Let's put a pressure reducing valve, right?
Mm,
It's just an example. That in that case, it costs a little bit more, but then you sleep better at night. You have much fewer issues coming back to you.
sure.
So in a lot of cases, it makes a lot of sense.
Mm. And it's one of those unseen savings, isn't it? Because the cost of either ignoring or kind of glossing over or missing this kind of thinking when you're designing the products and developing the product, the cost potentially could be catastrophic. Whereas the cost to actually implement these
Right.
ideas that you're talking about doesn't need to be really expensive. I mean, adding extra
Mhm.
batteries and things, sure, that probably is a decent cost. But as you've mentioned, adding in a valve or just selecting a component that doesn't have a sharp edge, maybe that's not really that critical, but it could save your bacon.
Right. And sometimes there are regulations and technical standards and so on that make it compulsory,
Mm,
right? And sometimes it's not compulsory, like what people call UL certification or ETS certification for electrical products for home use in the USA, right? It's not a must, but if you want to sell through retailers, if you want to have an insurance and so on, you better have it. Otherwise, you will be disappointed. So there are some mandatory or voluntary standards that will push you to consider a lot of these things.
yeah, yeah, which is really the name of the game about what we're talking
Mm,
about today. So, yes, this is a good one for anyone developing products right now. Definitely something to think about.
mm,
And I guess it's possible, like with anything, if you're rushing to get to market, could this be something where you kind of miss one critical question about, oh, hang on, what if that goes wrong? Could that cause a risk? Can these
mm,
elements or questions be missed? Absolutely they can. So it's always good to have the reminder. So we've covered, thinking about the failures, simplifying the product where
mm.
possible because there's less to go wrong,
Yeah.
adding redundancies if needed. We're in a critical area for sure, and
Mm,
making human error difficult to actually occur, such as with the good old British plug, as I mentioned, right? And of course, we're going to be testing, and there might be mandatory testing that would need to be done anyway, which will hopefully get you into the right track. So I think that wraps it up. And I will link to the blog post that you wrote some years ago. That's got a bit more detail about this. I suppose my final
mm,
question here would be about your design for the listeners, right? Are
mm.
you thinking, what
Yeah,
happens if X fails? That's the question to leave you guys with.
exactly. Yes.
Great. Okay. Thanks, Renaud, and thanks to everybody that's listening.
Great. Thanks.
Thanks again for listening to this podcast brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much, much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share because it will really help others discover us too.